Hey everyone, and welcome back to my science studio. In part 1 of my chemical composition series, we talked about how to find the percent composition of an element in a compound. In part 2, we covered empirical formulas, so how to find the simplest whole number ratio of atoms in a compound. So if you haven't watched those lessons yet, I highly recommend starting there first, because today we're going to be building directly on those. Speaking of which, to conclude our series, part 3 will discuss how to find the molecular formula. Also, the free worksheet we've been using is linked again in the description box, so you can easily follow along with me. What is a molecular formula? Well, again, remember, if the empirical formula is the simplest whole number ratio, then the molecular formula is the actual number of atoms in a molecular compound. So I want you to remember that the molecular formula is always going to be a whole number multiple of the empirical formula. In other words, it's not simplified. And here's the key equation I want you to remember for today. And so the molecular formula is going to be equal to the molar mass of the molecular formula, so in other words, the molecular weight, divided by the molar mass of the empirical formula. And so when we divide these two numbers, we're going to get what's called a multiplier. And that multiplier, we can take it and multiply it by every subscript in the empirical formula to figure out the molecular formula. So for example, let's say you have a compound that has an empirical formula of NO2 and a molar mass of 92.02 grams per mole. And the question is asking to find the molecular formula. So the first thing you want to do is to find the molar mass of the empirical formula, the simplified whole number ratio of atoms. And they give it to us as NO2. So nitrogen on the periodic table is about 14.007 grams per mole, and oxygen is about 15.999 grams per mole. But because we have two oxygens present, we have to multiply the molar mass of oxygen by 2. And we get 31.998 grams per mole of oxygen. Adding that number to the molar mass of nitrogen, we end up getting a total molar mass for NO2 to be 46.005 grams per mole. And that is the number that we're going to place in the denominator of our molecular formula equation, right? Because that's the molar mass of the empirical formula that was given to us in the question stem. Now, in the numerator, we have to place the molar mass of the molecular formula, and they give it to us. They say in the question stem that the molar mass is 92.02 grams per mole. So that's what we're going to place on the top of our fraction. Going ahead and dividing 92 by 46.005, we end up getting a number that's about 1.99978. And as you can see, we can round this number off to 2. That's the nearest whole number. That is our multiplier, the 2. So we can essentially take this 2 and now multiply it by the subscripts in the empirical formula of NO2. So 2 times 1N, we end up getting N2. And 2 times the number of oxygen, so 2 times 2, that gives us 4. So our molecular formula is N2O4. And one little quick tip for you guys, if your teacher gives you, say, the molecular formula, right? Like in this example, let's say the teacher gives you N2O4 and asks for the empirical formula. You can simply just divide the subscripts by their greatest common factor. So for example, N2O4, if you divide everything by 2, you'll get NO2, which is essentially the empirical formula, right? It's back to its simplest form. Okay, great. I encourage you to go ahead and pause the video and try this next problem on your own. And when you're ready, press play and we'll walk through it together. So the question reads, a compound consists of 85.6% carbon and 14.4% hydrogen by mass. Its molar mass is 56.12 grams per mole. Determine the empirical formula and then the molecular formula. Okay, so the first thing I want to do is find the empirical formula. So we're going to go ahead and write down the atoms that are present. We have carbon and hydrogen. If you remember from my last video, I taught you a trick that if you assume a 100-gram sample, we can easily convert the percent to grams. So we have 85.6 grams of carbon and 14.4 grams of hydrogen. But we can't have grams here, so we need to convert from grams to moles by dividing the carbon and the hydrogen by its respective molar masses. So for carbon, we get 85.6 grams divided by its molar mass, which is 12.011 grams per mole. The grams cancel out, and we end up getting 7.1268 for carbon. Hydrogen, we have 14.4 grams divided by its molar mass of 1.008 grams per mole, and we get 14.2857 for hydrogen. Now that we have moles, we notice that we have decimals here. We can't have subscripts as decimals. So we need to now divide by the smallest number present, which is 7.1268, so that we can try to get to the nearest whole number. So carbon, 7.1268 divided by itself is essentially 1. And hydrogen, when you divide 14.2857 by 7.1268, you end up getting about 2.004. And because this number is very close to 2, we can safely round it off so that our answer is CH2. Now that we have the empirical formula, we can go ahead and now find the molar mass of the empirical formula. So for carbon, we have 12.011 grams per mole. And hydrogen, there's 2 hydrogen atoms present here. So we got to multiply this 2 by the molar mass of hydrogen on the periodic table, which is 1.008 grams per mole. And that gives us 2.016. Taking this number and adding it to the molar mass of carbon, we end up getting 14.027 grams per mole as the molar mass of the empirical formula, so of CH2. And now we have everything we need to plug into our molecular formula equation. So again, they give us the molar mass, right, which is the molar mass of the molecular formula. So we take 56.12 grams per mole, and we're going to divide that by the molar mass of the empirical formula that we just calculated for, which is 14.027 grams per mole. When we divide, we end up getting the multiplier to be about 4. Multiplying this 4 across the empirical formula, so 4 times 1 carbon is 4, and 4 times 2 hydrogens is 8, giving us the molecular formula to be C4H8. And just a little tip before I conclude this lesson is that let's say your teacher gives you the empirical formula, so CH2, and the molecular formula, C4H8. And say they ask you to find the multiplier. All you got to do is ask yourself, what number do I multiply the empirical formula by to get the molecular formula? So in this case, we look at CH2, and so if we just multiply this by 4, we get C4H8. So the multiplier has to be 4. Sometimes it can really be that straightforward, so just make sure you read the question carefully. And that wraps up part 3 of my chemical composition series, where we talked about how to find the molecular formula. Thank you guys so much for watching. If you found this lesson helpful at all, please don't hesitate to like and subscribe to my channel so you don't miss another one of my lessons. I'll see you next time in my science studio, but until then, happy studying!